The point-to-point tunneling protocol is a method for implementing virtual private networks. PPTP uses a control channel over TCP and a GRE tunnel operating to encapsulate PPP packets. The PPTP specification does not describe encryption or authentication features and relies on the point-to-point protocol being tunneled to implement security functionality. However, the most common PPTP implementation shipping with the Microsoft Windows product families implements various levels of authentication and encryption natively as standard features of the Windows PPTP stack. The intended use of this protocol is to provide security levels and remote access levels comparable with typical VPN products. A specification for PPTP was published in July 1999 as RFC 2637 and was developed by a vendor consortium formed by Microsoft, Ascend Communications, 3Com, and others. PPTP has not been proposed nor ratified as a standard by the Internet Engineering Task Force. Protocol description: a PPTP tunnel is instantiated by communication to the peer on TCP port 1723. This TCP connection is then used to initiate and manage a second GRE tunnel to the same peer. The PPTP GRE packet format is non-standard, including an additional acknowledgement field replacing the typical routing field in the GRE header. However, as in a normal GRE connection, those modified GRE packets are directly encapsulated into IP packets, and seen as IP protocol number 47. The GRE tunnel is used to carry encapsulated PPP packets, allowing the tunneling of any protocols that can be carried within PPP, including IP, NetBay and IPX. In the Microsoft implementation, the tunneled PPP traffic can be authenticated with PAP, CHAP, MISCHAP v1/v2. Implementations: PPTP was the first VPN protocol that was supported by Microsoft dial-up networking. All releases of Microsoft Windows since Windows 95 OS are bundled with a PPTP client, although they are limited to only 2 concurrent outbound connections. Microsoft Windows Mobile 2003 and higher also support the PPTP protocol. The routing and remote access service for Microsoft Windows contains a PPTP server. The Microsoft implementation uses single DES in the MISCHAP authentication protocol, which many find unsuitable for data protection needs. Windows Vista and later support the use of PEAP with PPTP. The authentication mechanisms supported are PEAP-VO/EAP MSCUP2 and PEAP-TLS. Windows Vista removed support for using the MSCHAP-v1 protocol to authenticate remote access connections. Linux server-side support for PPTP is provided by the POP-TOP daemon and kernel modules for PPP and MPPE. Client-side Linux implementations of PPTP appeared in 1997, but the first widely used server-side Linux PPTP implementation was developed by Matthew Ramsey in 1999 and initially distributed under the GNU GPL by Murat and Bay. However, Linux distributions initially lacked full PPTP support because MPPE was believed to be patent encumbered. Full MPPE support was added to the Linux kernel in the 2.6.14 release on October 28, 2005. SUSE Linux 10 was the first Linux distribution to provide a complete working PPTP client. There is also a CCEL-PPPA, a Euro PPTP PPPoE server for Linux which supports PPTP in kernel mode. OpenBSD and FreeBSD both include POP-TOP in their ports trees. OS X and iOS include a built-in PPTP client, and OS X Server includes a PPTP service. Cisco and Efficient Networks sell PPTP clients for older Mac OS releases. Palm PDA devices with Wi-Fi are bundled with the Mergic PPTP client. Many different mobile phones with Android as the operating system support PPTP as well. Security: PPTP has been the subject of many security analyses and serious security vulnerabilities have been found in the protocol. The known vulnerabilities relate to the underlying PPP authentication protocols used, the design of the MPPE protocol as well as the integration between MPPE and PPP authentication for session key establishment. A summary of these vulnerabilities is below. Mischap v1 is fundamentally unsecured. Tools exist to trivially extract the NT password hashes from a captured MSCHAP v1 exchange. When using MSCHAP v1, MPPE uses the same IC4 session key for encryption in both directions of the communication flow. This can be cryptanalyzed with standard methods by XORing the streams from each direction together. Mischap v2 is vulnerable to dictionary attack on the captured challenge response packets. Tools exist to perform this process rapidly. In 2012, it was shown that brute force attack on MSCHAP v2 is equivalent to single DES key brute force attack. Online service was presented, which is capable to restore MSCHAP v2 passphrases MD4 in 23 hours. MPPE uses RC4 stream cipher for encryption. There is no method for authentication of the ciphertext stream and therefore the ciphertext is vulnerable to a bit flipping attack. An attacker could modify the stream in transit and adjust single bits to change the output stream without possibility of detection. These bit flips may be detected by the protocols themselves through checksums or other means. EAPTLS is seen as the superior authentication choice for PPTP. However, it requires implementation of a public key infrastructure for both client and server certificates. As such, it is not a viable authentication option for many remote access installations. See also, IPsec, Layer 2 Tunneling Protocol, Secure Socket Tunneling Protocol, OpenVPN, open source software application that implements VPN, references. External links, Windows NT, Understanding PPTP from Microsoft, FAQ on security flaws in Microsoft's implementation, Bruce Schneier, 1998, Cryptanalysis of Microsoft's PPTP authentication extensions, Bruce Schneier, 1999, PPTP VPN configuration.